In this video, we're going to take a look at how to solve a system of two linear equations in two unknowns. And the method we're going to take a look at is by using determinants. So first we need to look at how to solve a 2 by 2 determinant. And what I have here is a 2 by 2 determinant. It has 2 rows and 2 columns. And it has a place for each of the coefficients of my linear equations a and b. So we would have our linear equations a1x plus b1y equals c1 and a2x plus b2y equals c2. All right, so when your equations are in this form, you can use determinants to solve them. First, let's see, how do I even evaluate a 2 by 2 determinant? So a 2 by 2 determinant looks like this. And the way we evaluate it is a very specific method. We want to multiply the product of this diagonal right here. So we will have the a1 multiplied by b2. And then we want to subtract another diagonal, which is this one, which is a2 times b1. And that's how you evaluate a 2 by 2 determinant. The first one that I wrote is referred to as the principal diagonal, and the second one is the secondary diagonal. Big part of this equation is we are subtracting between the two. So let's do a numerical example to take a look at when we have some numbers involved. And so in this 2 by 2 determinant, we will multiply 4 by 5 and subtract the product of 2 by minus 6. Okay, so 4 times 5 is 20. We are going to subtract minus 12. That means we are doing 20 plus 12, and the result is 32. So this 2 by 2 determinant has the value of 32. Now, let's see how that applies to solving systems of linear equations using determinants. So to solve a system of two linear equations in two unknowns, we use determinants and something also known as Cramer's rule. So this is a formula for solving for the x value that is the solution to the system of linear equations. And it involves evaluating two different determinants. And the numerator is c1, c2, b1, b2, and the denominator is a1, a2, b1, b2. So, as I said before, the equations need to be in this general form, okay? So a1x plus b1y equals c1, and a2x plus b2y equals c2. So if you notice, the equations that we are solving for right here are not yet in that form. So that's something we should check for first, and we better put them in the correct form before we find the values of a, b, and c. So let's take a look at this one. The x term needs to come over and be on the left-hand side of the equation. So when I add x to both sides, it will be eliminated from the right side. We will have x subtract 4y equals, and the 17 will stay there. Now that equation is in general form. Let's do the same with the second one. It's the y term that needs to move to the other side of the equation and go after the x term. So we will add 4y to both sides. So this one is 3x plus 4y equals 3. Now we have the values that need to go into Cramer's rule formula. this equation up here is the a1x plus b1y equals c1. And so the value of a1 is a coefficient of x, which is 1. The value of b1 is -4. And the value of c1 is 17. The second equation is a2x plus b2y equals c2. And the value of a2 is 3, the value of b2 is 4, and the value of c2 is 3. So we must have the equations in this form first. Now let's fill in Cramer's rule. And so these are matrices symbols, and I will write them like that. Okay, they're not brackets, they are matrices symbols, which is an indication that we need to solve the value inside this 2 by 2 using the method as shown above. So C1, C2, these are the C values here. So we have 17, 3. And then B1, B2, well, that is -4 and +4. And in the denominator, we need to put the A1, A2, this is 1 and 3, and B1, B2, which is -4 and 4. Okay, to get this x value, we will have to evaluate 2 separate 2 by 2 determinants. And then in between them, there is a division. So let's not forget that, okay? It's not a subtraction. Okay, in the one in the numerator, we must do the principal diagonal, 17 times 4, and subtract the secondary diagonal, 3 times -4. For the denominator, the principal diagonal is 1 times 4, and the secondary diagonal is 3 times -4. Okay, let's see. 17 times 4 is 68. And we will be subtracting -12, which is the same as adding 12. In the denominator, 1 times 4 is 4. We are subtracting -12, so we are adding 12. 68 plus 12 is 80 over 16. Now it is the division. Okay, divide here. 80 divided by 16 is 5. If you didn't get an integer, then you can leave it as a fraction or convert it to a decimal value. All right, now we do have options. Once we know that x is equal to 5, we could take that value and put it into one of our original equations and solve using substitution. So that is quite a common way to go. So let's take a look at equation 1, which is x subtract 4y equals 17. And I'm going to sub in 5. All right, so 5 subtract 4y equals 17. And we're solving for -4y first. So -4y is equal to 17, subtract 5. Or -4y is equal to 12. Now y is equal to 12 over -4, which is equal to -3. So we do have the y value now. The solution then is 5 minus 3. But let's use this as an opportunity to practice solving for y using Cramer's rule. So I am going to give you the chance to fill in the values for the Cramer's rule for y. It's a little bit different. Let's first make sure we have our formulas so that you can see what the values are. And we'll put them down here so that you can see them. Okay. There they are. Okay, so take a moment, pause the video, and fill in the appropriate values and see if you can determine the y value, which we do know is -3 already, but it's time to practice. When you come back, I will take it up. All right, so for y, we have the determinant in the numerator and 1 in the denominator. The a1, a2 is 1, 3. c1, c2 is 17, 3. And for the denominator, a1, a2 is 1, 3. And the b values are -4 and +4. We multiply 1 times 3 and subtract 3 times 17. Put that over 1 times 4 and subtract 3 times -4. In fact, we've already done this one. We know that that value is going to turn out to be 16 because we did it above. All right, so up here we have 3 subtract 51, and it's going over 16. 3 subtract 51 is -48, and it's going over 16. And when we perform that division, it is -3. So that's another way that you can find the y value. So the solution is x was 5, y was -3. Thanks for watching.